you can count on O'Reilly to help you get back on the road fast.
Breaking news from the Makeshift News Network. BP's done it again, and this time their barrel of oil is spilling into Lake Conecuh.
Tragic story there, Jimmy. On a side note, did you know that Lake Conecuh is the only conical-shaped lake in the world?
No, Humphrey. I did not know that. That's a very interesting piece of information. Thank you for sharing.
Indeed it is, Jimmy. Did you know that it is also 40 meters across and almost 12 meters deep?
No, I didn't know that either. But did you know that BP's barrel of oil has a 30 centimeter radius and is 70 centimeters tall?
I did not know that. That is a very interesting fact. Lots of information.
So much
around
to
here.
learn, yeah.
I know. But did you know that our analyst, Dumb and Dumber, are here to help enlighten people on the situation?
Yeah, I knew that. Over to Dumb. Thank you. I'm Dumb. This is Dumber. We'll be explaining this problem.
Don't judge our
So,
names.
BP's barrel of oil is 30 centimeters in radius, and the height is 70 centimeters. And the instant that we're talking about, the height of the oil is at 40 centimeters, and is decreasing, the height is decreasing at a rate of 5 centimeters per second.
That's quite a lot.
It is quite a lot. So, to find the rate that the volume is decreasing in this barrel of oil, we first start with the volume of a cylinder, because the barrel of oil is a cylinder. The formula is volume equals pi r for radius squared times height.
Thank you, Dumb. I'll take it from
Over
here.
to you, Dumber.
Okay, so we want to get rid of one of these variables here because two variables, complicated math, we don't want to deal with that. We're going to replace the r because the r is directly related to the height. As you can tell, see the radius is 30 and the height is 70, which really means that the radius is 30/70ths of the height. Now, of course, that's a big number. You don't want to do that. So what you can do is take away the 10, and you usually get 3/7 as the height. You plug them into the equation. You can have the volume equals pi 3/7 h, because it is 3/7 of the height, squared, because you can't get rid of the 2, h. Square the inside of the parentheses, and you can simplify this entire equation down to the volume equals 9 pi, because 3 times 3 is 9, h to the third, because h squared times h is just h to the third, over 49. Back to you, Dumb.
From there, once you have this, take the derivative. The derivative of volume with respect to time is simply dv over dt.
Yes.
This is equal to power rule, this 3 and the 9 here, so power rule, 9 times 3 is 27 times pi, and then you subtract 3 minus 1, you get h squared.
Yes.
This is still over 49, and since you're doing the chain rule, you have dh over dt. You just multiply h with derivative with respect to time.
You can learn any of these in your basic calculus class.
Yes.
Very interesting. You should take it. Continue.
Indeed. So now you just plug in your variables. We have height, and we have the rate that height is changing with respect to time. So you have 27 times pi times 40 squared times 5, all over 49. Once you do all that multiplication and divide by 49, you get the derivative, no. The rate that volume is changing with respect to time is 138.487 meters squared, meters cubed, that should be cubed, per second.
Ah, yes. We don't have a lot here at the studio. Sometimes we mess up on our one whiteboard. Yes, thank you. Perfect.
We don't need computers.
Now, we started in centimeters, but we ended up in meters. This is important because Lake Conecuh is quite large, and we don't want to have it in centimeters because that would be huge numbers, and you don't want to deal with huge numbers. So we convert it into meters to make it easier to work with for the second part. We want to talk about the environmental impact of the lake and see how much fluid oil we're going to be pumping into it. So we're going to determine how high the water is the rate at which the water is increasing. So we can see if it's going to overfill anytime. You have to worry about your houses and your basements getting overfilled with black fluid, liquid stuff. That would not be fun. So Lake Conecuh is 20 meters across at the radius and 12 meters high. The water currently is 11 meters deep into the water, so it's not that bad. And to solve this equation, we're going to take the equation for volume of a cylinder, which is V equals 1/3 pi.
My co-host meant cone.
Cone, sorry, cone.
This is why I call him dumber.
Yeah. Of a cone, which is V equals 1/3 pi r squared h. Now, dumb will take over.
From here, right, hold on, I wasn't paying attention. Did you explain this part?
No, dumb.
Shoot, okay, so R. So what you want to do is take R in terms of height. So to do that, you find the ratio, basically, of radius to height, which is 20 over 12 simplified, divide. Divide numerator and denominator by 4, you get 5/3 times height. So radius is 5/3 of the height.
Perfect.
So that's in parentheses, you square that, and you do pretty much exactly what you did up here. Square the 525 over 9 times height squared, and then down here, since you have 9 and 3 on the bottom, 9 times 3 is 27, 25 pi on the top, that explains that. And then h squared times h is, in fact, h cubed.
Don't forget about that 1/3 here. This could mess
Right.
up your problem entirely.
This is
Now,
very important.
we're going to take the derivative of this, just like we did in the last problem. V becomes the dV over dt. Now, notice carefully here, we found the dV over dt of the last equation. We found how much oil is spilling into the lake. So that can be simply substituted in once we go to the next step. This equals 25 pi h squared. Using the power rule, you can take the 3, bring it down here. Now, if you notice there's a 9 here and not a 27 anymore, that's because when you bring the 3 over, it becomes 3 over 1. 3 divided by 27, or 3 27ths is really what's on the top now, and that really equals just 1/9, because you know, simplifying, 5th grade math. So you can get rid of the 27 and make it a 9, and keep the 25 there. This equals h squared. Now using the chain rule, make sure you use the chain rule, you get dh over dt on the side, because we're trying to solve for this part of the equation here. After this, you simply plug in your numbers. You get 138.487 as the dV dt equals 25 pi. 11 is the height at which it is right now, because if you notice we have height squared right here, and that's the current height of the lake squared over 9. Now to move into this step to solve out dh dt is on the right side. To solve for this is a little more complicated than the last one. We're going to have to take multiply 138.487 times the reciprocal of this, and that basically means flipping the fraction over to multiply 9 by this top instead of 9 on the bottom, because we are multiplying by dh dt. When you do this, you get 138.487 times 9 over the numerator, which is now the denominator, 25 pi 11 squared, which is just 121. To you, Dom.
This is correct. So, dh dt is simply these numbers divided by these numbers, and do all that stuff in your calculator, you get 0.13 meters per second. That is the rate that the height of the lake is increasing. So, every 10 seconds or so, the height is increasing 1.3 meters.
Which is quite fast.
Yeah,
considering.
anyone in the area might want to get out or do something about that.
Yeah. Now, if you excuse us, we need to move the camera down. We are very under budget.
We will, yeah. They couldn't hire an extra cameraman, but we have chairs though, so that's cool.
We do have chairs.
We'll be
Give
finding. Would you
John a
like to
second.
explain what we're finding here?
Yes, while we're moving, we're going to find the rate at which the area of the circle of oil that's pouring into the lake is increasing. The reason why we need to do this is to see how long it will take the oil to actually cover the entire surface of the lake, thus disrupting wildlife, destroying the ecosystem and stuff like that. And all that really sad things. But currently the radius is 2 meters across of the oil spill from the last update we got, and it's increasing at about 0.25 meters a second. And as you can see, this is just simply a topical view of Lake Conical, which is a perfect circle because it is a cone-shaped lake. The only one in the world,
That is,
FYI,
yeah.
if you didn't know that one.
Yeah.
The only cone-shaped lake in the world. Now, Del, would you like to continue?
Yes. So, what we're finding, we want to find the rate at which the area is changing. So, we have the area of a circle here, which is pi r squared. Very simple. Take the derivative of that, so rate of change of area with respect to time is equal to power rule here, so you have 2 pi r squared, or no, not 2 pi r squared, just 2 pi r, times chain rule, you get dr over dt.
Perfect.
Just like and up there.
Now if you notice, this 2, it just becomes down the bottom here because before we were multiplying it by whatever's in front of it, but since it's just a 1 here, you just end up with a, plain
Yes,
old
just
2.
r.
Just r.
2 and r.
Perfect.
Yes.
Just subtracting 1 from 2, it just becomes 1.
Yeah. And r to the first power is just r.
Okay, so in this problem we are trying to find how fast the area is, or the area of the circle is increasing to determine, the wildlife impacts. So dA over dt is what we're trying to solve for. This equals 2, if we plug in the numbers we talked about before, 2 pi, the radius is 2 currently, and it's going out at a dr dt is how fast it's going up, and that's 0.25. Now if you notice, 2 times 2, because you have to multiply this out like we've done all the other problems, is 4. But 0.25 is 1/4. 1/4 of 4 is just, is it 1, Kevin?
1/4 of 4. 4 over 4 is indeed equal to 1. 1 times pi is just simply pi. So the rate at which the area of oil is increasing is 3.14159265358979323 meters per second. And now over to Paul with the sports. Thank you for tuning in to channel 3.14159265358979323 846. We'll be back after the break.